let's let our first event be that we're going to flip a coin. And right now we're just going to flip it one time. Okay, we said earlier that our sample space, if I flip a coin, there are two things in there. We can flip a head or we can flip a tail. Heads and tails is what we usually say. So if I flip my coin one time and I want to know the probability that I flip a head on that coin, if I counted my sample space, there's one way to flip a head, and if we count the sample space up, there are two total items on that list. The probability that I'd flip a head is 1/2, and this experiment's pretty boring because the probability that I flip a tail, one way to get tails out of two possible outcomes. Half the time I get heads, half the time I get tails. Let's flip that coin. Let's flip that coin 2 times. We wrote that sample space down earlier on. I should have tried to copy and paste it over, but it didn't take me too long to write. So there's my possible outcomes. Maybe I ask for the probability that I flip 2 heads in a row. If I read through that sample space, there's only one time on the list, one way that I can flip 2 heads out of 4 possible outcomes. Maybe I want to know the probability that I'll only flip 1 head, and I don't care whether I flip it first or whether I flip it second, I just know that I want 1 altogether. When we count up those on the list, here's 1 head, there's another way for me to get 1 head. I'm going to change my pen back. So 2 ways of getting 1 head and 1 tail out of the 4 total outcomes. Now again, if my fraction's not in lowest terms, I need to go ahead and reduce it all the way. Maybe I want to find the probability that I don't get any heads. Then if I count that up on the list, there's 1 way of getting no heads at all. That's tail, tail at the end, out of 4 possible outcomes. So the probability that I flip 2 heads in a row happens 1/4 of the time, or that probability is 1/4. Probability that I get 1 of each happens half the time, and a probability that I don't get any heads at all, that should be equal to 1/4. Maybe I want to flip that coin 3 times. And again, we wrote down that sample space earlier, and we made a list. But I also want to show you another way that sometimes is kind of helpful and useful to us to help visualize what's going on in an experiment that either is repeated several times or maybe I have some stair-step events. Maybe I flip a coin and then I roll a die and then I do something else. So, and what I'm going to draw is what's called a tree diagram. So I pick up a coin and I throw it up in the air and it comes down. And so if I write down on the first flip what might happen, it's probably one of the kitties, I can get a head or a tail. I'm going to put my head on top just because my OCD wants it there. Okay. But it doesn't matter what order you put them down. Also remember in these that the outcomes are equally likely. If I say roll a 1 or roll something else on my die, those outcomes are not equally likely. And while I can use a tree, we'll add that step in another section. Okay, right now, equally likely outcomes. Okay, so now it doesn't matter what landed on the ground the first time. When I pick up the coin the second time and I throw it up in the air and let it fall down on the carpet, okay, whether I rolled a head or a tail the first time, rolled meaning flipped, it's those same possible outcomes the second time as well. Notice from the 2 flips, if we follow these branches from the beginning here at the point to the end, those are the 4 outcomes in the sample space that I had on the page before. I can go head, head. I can go head and then tail. I can go tail and then head, or tail and then tail. when I pick up the coin and throw it one more time. I'm going to make my branches a little skinnier, but it doesn't matter whether I flipped heads or tails in the first flip, and it doesn't matter what I flipped in the second flip. When I throw that coin up in the air the third time, it's either going to land on a head or it's going to land on tails. And if you go back to the first page, I think probably a video ago, it had that sample space written down. We had head, 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 tail. Head, tail, head, head, tail, tail. We can go tail, head, head, tail, head, tail, 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 head, tail, tail, tail. Those are our 8 possible outcomes. So I could either list those 8 things in my sample space and count if I'm asked to find a probability, or I might be able to picture it from here on a tree. Okay. Let's count the number of heads again, just to make it similar to what we did on the last page. So if I want to figure out the probability that I'm going to flip no heads whatsoever, okay, I'm going to follow these branches here and look until I get to one that doesn't have any heads in it, okay, which is tail, tail, tail. There's only one of those 8 possibilities that had no heads. If we count up all the branches, 1, 2, 3, 4, 5, 6, 7, 8, there's 8 total possible outcomes in this experiment. Back to fat pen. Maybe I want the probability, circle in purple so we can see and match. Maybe I want the probability of getting 1 head, and 1 head only. Okay, when it says 1 head, it means exactly 1. If it says 1 or more, or at least 1, that encompasses more than 1 thing. But if it says the probability of getting 1 head, it means 1 and only 1. So here there's 3, here there's 2, and there's 2, and here's 1 with only 1 head. And then there's 2 heads, and there's 1 head only, and here is 1 head only. So here in this box, I'm going to make blue. We said there's 3 ways of flipping 1 head out of the 8 possible outcomes there. Notice the denominator is going to be 8 in all of these, at least initially. Sometimes I can reduce to lower terms, sometimes I can't. So go ahead and continue this thought and pause the video here in a moment and count up and find the probability that we'd flip 2 heads. That means exactly 2 heads and 1 tail. And then find the probability that we would get 3 heads. And when you unpause the video, the answers are going to be there, so don't turn it back on until you're ready to see the answer. Alright, so if you check out my arrows over there on the diagram, there's 3 ways to get 2 heads and 1 tail out of my 8 possible outcomes, and 1 way to get all 3 heads and no tails out of the 8 possible outcomes. Okay, notice what happens. These are all of my possible events. If we're talking about number of heads, I can get 0, 1, 2, or 3, and there's no others. If we add up all of these outcomes, notice that it adds up to be 1. Over here, I could either flip 2 heads or 1 head or 0 heads, and notice that if we add up 1/4 plus 1/2, which is 2/4, and another 4th, all of those add up. If we add them up, we get 1. What an ugly way to write that, but if you take, and that'll always happen. So if we want to find the complement of an event, and I'm going to save that for the next video. This one's getting long. My internet's slow enough at home, it takes forever to upload these. So next video, we're going to talk about some card drawing some cards out of the deck, and we'll talk complements there in that set of exercises.